Hello everybody, welcome to my Planetarium show for June of 2021. And I've chosen to set this up initially for the morning of June the 10th, where there's a rather special event going to happen. So let's get things moving. What we're going to do is aim up towards the sun at around 10 o'clock in the morning. And hopefully, if it's a nice sunny day on Thursday the 10th, then we will be able to see a partial solar eclipse, the first one for quite some years to be visible from England, and in particular Cambridge, where I'm based. So here we have the sun and the moon just visible there in the image on the screen. Of course, you won't see the moon like that because the sun's so bright. And of course, don't look at the sun with any form of optical aid, or indeed without the protection of proper eclipse glasses or some sort of eye protection, because you will damage your eyes. But this is what the moon is going to do. It's going to pass across the face of the sun. It's not going to block out more than about a quarter of the total disk, so it won't make the sky go dark. And in fact, if you're not aware that the eclipse is in progress, you probably won't even notice it. Starts at around 10 past 10 in the morning and will be at its maximum about 11:15, and then finish after noon sometime. So you've got a window of about an hour, around about 11, when it's best to see it. As I say, look using eclipse glasses that are really dark, or find some way of projecting the image onto a screen rather than observing it directly, so that you don't hurt your eyes. So we're now running forward. The moon is moving away from the sun in the sky there as it goes along its orbit around the Earth, and we're letting time run down to sunset. So the sun just on the horizon there. And what we're going to do now is have a look just above the tree line here. We've got a very bright object, and that's the planet Venus. So with this software, I can zoom right in as if I have a very powerful telescope. And here we see Venus, and you can see that it's showing round about a 3/4 phase disk. All we can see, of course, with Venus is the cloud tops. It has such a thick atmosphere, over 100 times as dense as our own atmosphere. Very, very thick indeed. We can't see through it to the surface at all. Only by dropping probes in have we been able to discover what's going on beneath the cloud tops. So that's Venus, and you will have to, just as the sun is setting, just as the sun's gone below the horizon, is the best time, but you'll also need a very low, clear horizon without any tall trees, because otherwise it will be obscured. So quite a narrow opportunity to see it just at the moment. So we've pulled back there again, and you saw it disappear just above the tree line. So we'll let time run forward a little bit further, on till 10 o'clock, in fact. And that will get the sun a little bit further below the horizon. Of course, at this time of year, it doesn't stay down for very long. There's Venus, very, very bright right on the horizon. But now, just above the tree, we've got three things. We've got the two bright stars of Castor and Pollux in Gemini, the heavenly twins. But here we're going to zoom in on Mars, the red planet. Mars is now getting quite a long way away from the Earth, and so it's looking like a rather smaller disk to us, even through our telescopes. It's got two moons, Phobos, which is just hiding behind the planet there, and Deimos, that you can see. If we zoom in closer to the disk, you'll see the polar cap up there to the top right, and the dark desert markings, one or two crater-like features. Some of those are impact craters, some of the tops of extinct volcanoes on the surface of Mars. There are no active volcanoes left as far as we know. But we'll pull back away from Mars and look at it another time, because it really is getting too far away for us to see properly in great detail now. But I just thought I'd show that it was still visible even in the twilight there. So now we'll run on until the sky gets properly dark, and really that's only between the hours of around about midnight through till about 2 o'clock in the morning. Of course, we're on British summertime, and so 1 o'clock is the true astronomical midnight. So now we're looking south, and we have the constellation of Bootes the herdsman, with the very bright star Arcturus marking out the bottom of the kite-shape arrangement. There's the graphic of the herdsman himself. You can see the bright star Arcturus. Let's zoom in a little bit closer. It's relatively nearby, only 37 light years away, and just a little bit more massive than the Sun. But it's somewhat older. It's 7 billion years old. The Sun is around 5 billion years old. And as a result, it has already entered the red giant stage of its existence, where it's swelled up and cooled its surface as it reorganizes its inner workings. So that's Aldebaran. But I've chosen this particular spot to stop at just 2 minutes past midnight. And the reason for that will become clear, because as we suddenly let time run forward again, you'll suddenly see the Starlink satellites make a parade. There they go, all whizzing up through the constellation of Bootes. You can use Arcturus as a signpost. So you can see a stream of Starlink satellites. And at the bottom, traveling horizontally, there's the Lacrosse 5 American spy satellite. They still don't admit these Lacrosse satellites exist, but they're very bright and easy to spot. So they're not fooling anyone. So that's just at 2 minutes past midnight on the 10th of June. If you've got a clear sky, find Arcturus to the south and fairly high up as a signpost, and you'll see that event happen. Just to the left of the constellation of the herdsman, the kite-shaped one there, we have the Northern Crown, Corona Borealis. An interesting little constellation. Really does look like a crown, even just with the stick diagram. And there aren't any tremendously bright stars in it, but it does contain quite a range of interesting galaxies. So if you're interested in searching for relatively difficult galaxy targets, then that's a good place to go at this time of year, inside the bowl of the crown there. We're going to now move a little bit further over to the left to the constellation of Hercules and Hero. And this has a characteristic 4-star keystone shape arrangement, which you can see there. We're now going to line up on it. And there's the stick diagram showing the keystone arrangement. So you've got Bootes, then Corona, and then Hercules. There's Hercules the hero. He's upside down, of course. A lot of things in astronomy are up the wrong way. There's just something you have to get used to. Now we're going to look along one edge of the keystone formation here and center up and zoom right in. You can see a fuzzy patch already. And here is one of my favorite objects, the Great Globular Cluster, Messier object number 13. This is one of about 400 globular clusters that are like microgalaxies that orbit round the outside of the Milky Way. Indeed, they may be the nuclei of defunct galaxies that have come too close to the Milky Way and been stripped of all of their other outer layers. So that was Messier 13. Here's another one, Messier 92, also in Hercules. Again, around about 500,000 stars, all packed together quite tightly. And these are very, very old stars. As I said, I think there's probably a small black hole right in the center. And these are actually the nuclei of stripped galaxies. So we'll pull back away from that one and look at the third one, also in Hercules, just to make the point that there are an awful lot of these, and you can go surfing from one to another. This one's called the Prize Comet Globular Cluster. It's one of the more distant ones, 100,000 light years from us, and often gets mistaken for a comet, which is why it has that rather curious name. But well worth chasing some of these down. They always look to me like diamonds on a velvet cloth with the stars shining against the darkness of the outer background of space. So we'll move on now away from Hercules and have a look at some other objects that we don't usually hear very much about. I've picked a couple of unusual ones for the remainder of this tour. And one of them here is down in the constellation of Scorpio, the Scorpion, and it's the Blue Horseshoe Nebula, where there's a lot of blue light reflecting back off a cloud of gas and dust. The blue light is coming from that very bright star. It's a very hot star, hotter even than white hot, so giving off a lot of blue light. And the blue light is hitting the gas and bouncing back to us. So it's called a reflection nebula. And that's just in the constellation of Scorpio. But there are so many objects in Scorpio in this part of the sky. You see the bright red star Antares just at the bottom of the screen there. Antares means not Mars in translation, because it's a very similar color to Mars. But we also got this constellation, Ophiuchus, and this is one that is very rarely talked about. It's actually the 13th member of the constellations of the zodiac, but somehow got left out, perhaps because 13 is an unlucky number in some people's opinion. But it's quite a big constellation, and as such has a number of interesting objects in it. And one that I particularly like is called the Ghost of Mars. Here it is. Again, it's a round disc-like object, and so in poor telescopes it looked a bit like a planet. They called it a planetary nebula. What you've got is right in the center there, the dead white dwarf star that has blown off its outer layers into a smoke ring in space, forming that circular feature that we could see. So that's the Ghost of Mars, a planetary nebula, the remains of a sun-like star. The sun will form one of these giant smoke rings and blow its outer layers off into space in the very, very distant future. It's not something you have to worry about anytime soon, of course. What we're looking at there is the star clouds of Sagittarius, the densest part of the Milky Way as it's descending towards the horizon. And it's very dense there because we're actually looking towards the center of the Milky Way galaxy, where the enormous bulge of stars is, very, very crowded region. Letting time run forward again now, we've got a few, the blue markings there are where meteor showers sometimes come from. They're called the radiant points. And the software Stellarium that I'm using for this show shows you where those radiant points are for different meteor showers. If you want to know more about that, look at one of my other talks on shooting stars and space rocks, I think it's called. So now it's the early morning, 2:30, and we're going to have a look at Jupiter, the king of the planets. Here it is, and this is what you would see with a small telescope. There are a couple of stars there, and 3 out of the 4 big moons, the Galilean moons, that are sort of almost planet-sized in their own right, orbiting around Jupiter. The 4th one is hiding behind Jupiter on this particular occasion. But here we have the planet itself, as you would see it with a very powerful telescope, with the dark, dusty, brown cloud belts running around just north and south of the equator, other belts, lots of white whirls and spots to see. Those are all giant hurricanes in the atmosphere of Jupiter. But we're going to move off and have a little look at its moons. This is Io, and Io is the most volcanic place in the solar system. All those features that you see on the surface there are volcanoes. Now you can't see it like this with a telescope. This is an image from the Voyager spacecraft that flew past it. And it shows it covered in all those yellow and orange colors. Those are all different forms of sulfur from the volcanoes. Now, just as an extra, here is one of the little moons of Jupiter, the tiny potato-shaped small moons, called Amalthea, and it's very red in color, covered in what material that we think is made of chemicals called tholins, which are carbon, hydrogen, nitrogen based compounds that may be the precursors of living molecules. So that's Amalthea, one of the inner but rather small moons. Going to the largest moon in the solar system now, this is Ganymede. It's actually larger than the planet Mercury. So if this orbited the sun, we would call it a planet. But because it orbits the planet Jupiter, we call it a moon. Covered in glaciers and ice flows, one or two impact craters on the surface there, very interesting mixed terrain on the surface of Ganymede. And the fourth moon of Jupiter that we're going to look at is Callisto. This is just a little bit smaller than Ganymede, but still a planet-sized moon in its own right. This has a lot more of the craters on the surface and not so much of the other types of geological activity. It's a very ancient and dead surface in that respect, whereas Ganymede seems to be undergoing various geological processes right up to the present day. So that was the Jupiter system, and you can see Jupiter there above the southwest horizon at about 2:30 in the morning. To its right is also the planet Saturn, not quite as bright. Saturn's smaller and further away, so that explains why. A small telescope will show you it like this, with the rings and the disk of the planet in the center there, very spectacular, and some of its moons. It's an interesting challenge to figure out how many of its moons you can track down. You'll almost always be able to see the big orangey one at the right there, Titan, just gone off the screen. As we zoom in on the planet itself, you can see the gap in between the main A and B rings, called the Cassini division, and the lesser gap right towards the edge in the B ring, called the Encke division. You can also see how the disk of the planet is casting a shadow on the rings. Now we've swung over to Titan, the largest moon, again, a planet-sized moon with an atmosphere 1.5 times the density of the Earth's atmosphere. So a very interesting world, covered in this orange smog layer in the atmosphere, made of organic chemicals. The atmosphere is mostly nitrogen, with things like methane and carbon dioxide present as well. And it seems to have lakes of liquid methane and rivers and a whole weather system based on methane rather than based on water as we have it, because the temperature there is minus 160 degrees. So the same physical processes, but based on different chemicals. So that was Saturn. And as a final object, we're just going to peek right on the horizon here at the Helix Nebula. Absolutely beautiful object if you can track it down. This is a planetary nebula. It's perhaps the most impressive. You can see right in the center the white dwarf star, that little white speck. That's the dead core of the star that has blown off its outer layers to make those very beautiful smoke ring patterns of glowing hydrogen gas in space. And that's really very, very tricky to see from the UK, because it's only just above the horizon for about half an hour at this time of year, right in the middle of the night. So you need a very, very low southern horizon in order to catch that one, but it's worth trying. So I'm afraid our time has now come to an end. We're going to run time forward towards dawn to about 4:30, and we will see the stars fade. One or two satellites whiz across, of course. There are so many of them up there these days that you can hardly avoid them. But do try and follow along and track down some of those objects, and I hope you manage to. So thank you very much for listening, and we'll see you again for the next one in a month's time.